All right, let's talk about one of the most incredible technologies of our time, the solar panel. Today we're going to break down exactly how this simple, flat panel takes pure sunlight and turns it into the electricity that powers our world.
Okay, so let's dive right in with the central question. You look at a solar panel, it's completely still. There are no turbines, no gears, no combustion. So how in the world does it create energy? It feels like magic, but it's actually some really elegant physics at work.
So the secret sauce here is a phenomenon called the photovoltaic effect. That's our key phrase for today. It's the fundamental process where a material like silicon has this amazing ability to convert photons, the tiny particles of light, directly into a flow of electrons, which is, of course, electricity.
So, how does this effect actually work? To understand it, we've got to zoom way in and look inside the solar cell itself. We're going to witness what I like to call the dance of the photon.
A solar cell is basically made by sandwiching two slightly different kinds of silicon together. On one side, you have N-type silicon, which is doped, meaning impurities have been added, to create a bunch of extra free-floating electrons. And on the other side, you've got P-type silicon, which is doped to have an excess of holes, or basically empty spots where electrons should be.
Okay, so this breaks down the whole process for us in 4 steps. First, when you put those two types of silicon together, they form what's called a p-n junction. Right at that border, electrons jump over to fill the holes, which creates a powerful one-way electric field. Then, a photon from sunlight comes in and smacks into the cell, knocking an electron loose. And finally, this is the crucial part, that built-in electric field immediately separates them, pushing the electron to the N side and the hole to the P side.
And that forced separation, that is everything. By pushing the negative electrons one way and the positive holes the other, the cell creates a voltage difference, just like a battery. You connect a circuit, and those separated electrons will flow to create a current, and that is solar power.
Okay, so now that we've got the science down, let's zoom back out. Because that fundamental process has been engineered into a whole family of different solar technologies, each with its own strengths and weaknesses.
This table gives us a great bird's eye view. The two most common types you see on rooftops are monocrystalline and polycrystalline. Mono is made from a single pure silicon crystal, giving it higher efficiency but also a higher cost. Poly is made from multiple crystals, which makes it cheaper but a little less efficient. Then you have flexible thin film cells and the exciting new kid on the block, perovskites.
And believe me, that efficiency gap really matters in the real world. For example, monocrystalline panels can hit around 22% efficiency, while polycrystalline are closer to 16%. That means for the same amount of power, you need a bigger chunk of your roof covered in poly panels. So the choice often comes down to a trade-off between your wallet and your available space.
Now let's talk about the future, perovskites. This is the technology that has researchers incredibly excited. In the lab, they're showing the potential for super high efficiency at a really low manufacturing cost. The main challenge right now is durability. They're still too unstable for widespread use, but they represent a massive leap forward if we can crack that nut.
So we've got the science, and we've got the different types of cells. Now let's connect all this to the real world. What's the actual impact of this technology on our lives and our planet? The benefits here are just huge. Solar is a clean, renewable, and totally silent source of power. Since there are no moving parts, the maintenance is incredibly low. It's also amazingly scalable. The same basic tech that powers your pocket calculator can be used to build a massive power plant. It helps homeowners and entire countries become more energy independent, and it's a crucial tool in the fight against climate change.
But maybe the single biggest driver of solar's growth is this number right here, 80%. That's how much the cost of solar panels has plummeted in just the last decade. It has made solar power not just an environmental choice, but a powerful economic one for millions of people and businesses.
And because of that price drop, we're seeing it deployed absolutely everywhere. From residential rooftops that give families control over their electricity bills, to commercial and industrial sites powering factories, all the way up to huge, utility-scale solar farms that provide clean energy to the entire grid.
The growth has been explosive, but really, we're just getting started. So what does the road ahead look like? What's the future for photovoltaics?
Well, it's a road with both challenges and incredible opportunities. The biggest challenge is variability. The age-old question, what happens when the sun isn't shining? That's why energy storage is so critical. But the opportunities are even bigger. Perfecting new materials like perovskites, integrating solar directly into our buildings and infrastructure, and completely transforming our energy grid to be cleaner and more resilient.
The roadmap to get there is pretty clear. We need to keep developing cells that are more efficient and last even longer. We need to build out energy storage on a massive scale, like huge battery farms. And we need to get creative, integrating solar technology invisibly into our cities. Think solar windows, solar roads, even solar fabrics.
And the ultimate goal behind all this innovation, well, it's truly profound. It's about the potential to bring clean, affordable, and reliable energy to every single corner of the planet, empowering communities and improving lives in ways we're only just beginning to imagine.
So I'll leave you with this final thought. One breakthrough in battery storage, one new super-efficient material like a stable perovskite, are we just one key innovation away from being able to power our entire world with the sun? The dance of the photon is still going, and the future it's creating looks very, very bright indeed.